We want to look at another type of gas law problem. Again, for this one, you want to label as you go through the problem. So this first one I see is milliliters, so I know that's a volume. And then I see a temperature, and I see another temperature, and then it wants me to find another volume. So wherever the volume is starting, that's going to be your T1. So the 1's go together, and the 2's go together. Now we have a little bit of a problem here. Our temperature is in degrees C, and we need Kelvin. So we're going to have to do a couple of conversions. So I'm going to do those real quick. Remember, you add 273.15 to actually convert it to kelvins. And we're not doing any rounding or significant figures until we are completely finished. So now I've got my two new temperatures in kelvins. Remember, they're not really new, they're just in a different unit. Now, if this is volume and temperature, that's Charles's law, so we're going to have V1 over T1 equals B2 over T2. So when I plug in what I know, I have this in milliliters. And some of you may be saying, well, but don't I need to convert that? Well, you only need to convert it if it says your answer is going to be in liters, and you can always do that at the end. There's nothing wrong with it. So I'm looking for my other volume. So you're going to cross multiply and set equal. We want to get V2 by itself. We're going to divide both sides by everything in front of it. So these cancel. I do the left-hand side on my handy-dandy calculator, and you should come out with 1.15 milliliters as your second volume. And remember, you want three significant figures because that's how many you have in your original equation for volume.